Actually, besides the basic rules in the Armstrong axioms, we can also derive some more complex rules by using them. And we also show some examples in this page. The first rule we can create is called union rule. Given two existing FDs, x implies y and x implies z, we can derive a new FD, x implies yz. We can show this first and then we can prove it. The second one is called decomposition rule. Given x implies yz, then we can get x implies y and x implies z. You need to consider how to prove it, right, in your mind. And the third one we have is called Pseudo Transitivity Rule. Given two FDs, x implies y, yz implies u, then we can get a new FD, xz implies u. Actually, all these rules can be derived based on the Armstrong axioms. I will show you how to derive them. So before I show you the answers, you can pause the video here and also derive these rules by yourself first on your paper. And then I can show you the answer. You can compare with my proof. Okay, let me show you the answer, how to prove them based on the Armstrong's axioms. Let me copy the rules and into a new page, and we can derive them one by one. Okay, so the first one is called the union rule, right? We can prove them based on Armstrong's axioms. So for the union rule, given x implies y and x implies z, we can get x implies y and z, right? How can we prove it? So we can prove it by using this augmentation rule we showed before. Let me also show you the Armstrong axioms. We have one augmentation rule shown here, right? If we have a1 to an implies b1 to bm, then we can augment both sides with some new attributes, right? Now c1 to ck. By using this augmentation rule, we can derive the first union rule. What we can do here is, based on x implies z, we use augmentation rule, right? And get what? Get xx implies xz, right? It should be easy to understand, right? We add both x to the left-hand side and right-hand side, right? And based on xx implies xz, what can we do next? What's more, based on this first union rule, we can also get we can get what? We can get x implies y, right? And we can further use this augmentation rule and get what? Get x z implies what? Implies yz, right? You can follow this, right? We add both z to the left-hand side and right-hand side. This is the second one we can get. And then based on the x implies xz and xz implies yz, we use the transitivity rule, right? You should know the transitivity rule, right? Given some attributes a1 to an implies b1 to bm, as well as b1 to bm implies c1 to ck, then we can get a new FD, a1 to an derives or implies c1 to ck, right? So by using the transitivity rule and based on the existing two FDs, we can get xx implies what? Implies yz, right? What is xx? Xx actually is x, right? Because they are the same copy of the same attributes. So then we can get X implies YZ. Right. So by using both the augmentation rule together with this transitivity rule, we can prove the first union rule based on Armstrong's axioms, right? So the first proof. How about the second one? Second one should be easy to prove, right? Let me show you how to prove it. This is union rule proof. The second one is called decomposition rule, right? Proof. So given X implies YZ, and we can get X implies Y and X implies Z. How can we prove it? So first of all, based on X, so first of all, based on one rule, it's called the reflexivity rule, right? Given A1 to AN, we can imply any subset of A1 to AN, right? By using this reflexivity rule in the Armstrong axiom, we can derive it based on reflexivity rule. We can get the first one we can get is called YZ implies Y, right? And YZ implies Z, right? So based on reflexivity rule, can decompose, we can get YZ implies both Y and Z, right? Because they're a subset of YZ. Then what? Based on the transitivity rule, right? We can get X implies YZ and YZ implies Y and Z. And YZ implies Z, right? We can get the first one we can get is X implies Y, right? And Y and X implies Z, right? So for the second one, decomposition rules, we can prove it based on both the reflexivity rule together with the transitivity rule, right? And we can prove it. How about pseudo one? Pseudo transitivity rule. How can we prove it? It should be easy, right? I think you have the proof in your mind or on your paper already. Let me also provide you with a proof for the pseudo one. It's called pseudo transitivity rule. How can we prove it? So the first one is, given X implies Y, what we can do here is to use the augmentation rule, right? Okay, we have X implies Y by using the augmentation rule. We get what? We get XZ implies YZ, right? We add both Y to the left and right hand side, and we can get this XZ implies YZ. Then second one will be, we know YZ implies U, right? And by using what? By using the transitivity rule, right? We can get what? So by combining XZ implies YZ, YZ implies U, we can get XZ implies U, right? So pseudo one can be proved by using both augmentation rule together with the transitivity rule. So I think you should be able to prove these rules by yourself based on the Armstrong's axioms. This is my proof. You can check with yours and to see if your proof is correct or not. There are different ways to prove it. Of course, besides my proof, you can also prove it in different ways. That should be fine. Okay, so this is about the derived rules we can get based on Armstrong's axioms. Next, we will talk about the closure of the attributes.